Hello everyone, welcome to this channel and I hope everyone is doing good. So in today's video, we are going to look into the RAG pipeline practicals. In our previous video, we have seen RAG interview question, LLM interview question, multiple RAG concepts in some of the practical form, some of the theoretical form. We've also seen the vector database, ChromaDB practicals. So in today's video, we'll build the full pipeline from the starting to end in a very simplified way. We'll try to understand in a very simple form. And this video will be specific only to create a RAG pipeline. We are not going into any optimization framework, any optimization steps in this particular video. In the next video, I'll come up with the optimization things, practical of the optimization in the same RAG pipeline. So let's start the video now. So first of all, we'll understand what is the requirement. So requirement is to build the RAG pipeline on the data set, and that data set is the wiki page. So I have this wiki page. This wiki page is on Shahrukh Khan, and I've just copied all the content of the wiki page in one document, and that document will be the source. That will be the source for our RAG pipeline. Okay. So I have. Okay. So there is a document. I'll just show you the document. If you click on this document, I have just copied everything from the wiki page, and this document will be used as the input to the RAG pipeline. We'll do the chunkings and the embedding of this same document. So now we'll go to the RAG demo file, the Python file. So the code is already written and I've tested this code. So we will be going to use the version in which I have used the ChromaDB. Okay. So in this ChromaDB, we are using ChromaDB for the vector database. We'll try to understand each thing from the starting. So the first thing is the environment variable. So why we will need an environment variable? Why we need to load the environment variable? Because you are going to use the OpenAI. You can use environment variable for importing any of the parameter. But for this use case, I have used this for OpenAI key. So this variable I have created. See here the environment variables. This variable contains the value of this, the key of this. So if you have to for using any LLM, just if you are using OpenAI LLM. So go into OpenAI website, and there you can just sign up to the website and create an OpenAI key. You have to pay for it. You can just put $5 initially, and that will be sufficient for doing all of your R&D and the POC. So this is for the environment variable. Now I'm using the LangChain for building this RAG pipeline. So what is LangChain? So LangChain is a framework which helps you to integrate the external tool, external framework, external source to your LLM. So you have an LLM, but you have to build some application on the top of LLM. So you need some framework which will help you to get all the important libraries, do multiple things without writing the code for each and every steps. So that framework is LangChain. Similarly, we have a LangGraph also for the multi-agent application that I have already discussed in our previous video. So we are going to work on a LangChain in this particular use case. So for loading the document, we need something which can load this document and create into document type. So for that, I have imported LangChain community version document loader. So this will import this text. This will read this my document.txt, and this will create a document object of it. So this document object is created, and then this can be used as chunkings, embedding in the future. The other import is the splitter, because we will be splitting this document. Like if you already know the process of in the RAG, we first import the data and we do the chunkings. So our first process is to import all the necessary libraries, get the source data. That source data can be from anywhere. In my case, I have used a simplified form, a local version where I have kept the my document.txt, which I have just copied the wiki page of the Shahrukh Khan wiki page to this my document. Now this splitter will split this document into different chunks depending on what is the chunk size which we provide and other configuration unit. Then I'm using for embedding, I'm using the OpenAI embedding because I'm going to use the OpenAI LLM. So this will be helpful for creating the embedding. Then I'm going to use the ChromaDB for the vector database. OpenAI is used, so I've imported OpenAI. Then LangChain's retrieval. This is the way which will retrieve this will be helpful for getting the retrieval chunks from your vector database. We'll see all this practical. So our first step is completed, which is importing the libraries. Then we have imported this environment variable, and here we have the document which we have imported the document. See, I have hard coded everything here, but you can keep all this in some other parameter file or in the environment variable also. But generally people keep it in different parameter file, not in environment variable, and there you can parameterize everything. For our demo purpose, I have used this as a hard code, but this is not the standard way how we do in the any organization. Now we will go and split the size, split this document size. So how we will split this document size? We have imported recursive splitter. So we'll use this recursive splitter, text splitter, and we are giving the chunk size and the chunk overlay. Chunk size 500. So 500 words and the overlay is 50. 50 means like if I have chunk 1 and chunk 2, then 50 words of chunk 1 will be same as 50 words of chunk 2. The same word is getting copied into the other chunk. That means the 50 word will be common in chunk 1, chunk 2, then again chunk 2, chunk 3. Why so that chunk 1 is connected to chunk 2 with in a meaningful way. So we keep some overlay. So these all parameters need to be looked into in very detail if you are working on the performance of the rack, performance tuning of the rack. But for our understanding, we have a chunk size and we have a chunk over. Now this document chunks is created with the help of a splitter. So after this, your document, for example, your document has multiple parts. So after this, you will have some specific number of documents part. For example, 20 documents or 30 documents, depending on how the chunking has been done, depending on 550. Fine. After this, we are going to do the embedding. Okay, so we have initialized the embedding. We have not done the embedding, we have just initialized the embedding. And with the help of vector database ChromaDB, we will be doing the embedding. We will be storing the embedding. We will also store the original text and the other metadata information. We will see it now. So now why vector DB? So vector database is a way where, like, vector data is a database where we keep all the embedding. So understand what is embedding. So I have seen in many of the interviews, people are able to explain the RAG pipeline, but they fail to make, or they fail to understand, or they fail to explain the vector embedding. What is embedding? So in a simple term, what is embedding? Embedding is creating a multi-dimensional vector by assigning the vector in numerical terms to chunk. For example, you have 500 chunks. So each chunks will be given one numerical values, and that numerical values will be assigned into a multi-dimensional vector database. So vector database will store in a multi-dimensional fashion, not in a two-dimensional. So there will be multi-dimensional in a ChromaDB. So you can limit it to 3D or to 2D version. Embedding is assigning that number to the chunks. If you want to know more details how this embedding works and how this internal of this ChromaDB multi-dimensional vector works, I have already created a very detailed video on that. I'll put it in the I link, and that will be helpful. Please go through it. That will make you very clear like what is actually embedding. Then in any of the interview, if the interviewer asks any question on the embedding, you'll be able to explain it with very great logic. Okay, now we'll see this term, what we are going to do in a vector database or a vector store. So now in the vector store, this variable, what we are going to do, we are going to create the embedding. That embedding is getting stored into vector database under this collection, and the actual text is also being stored into this vector database, plus the metadata information is also being stored here. Now, what all things we have done? We have imported the libraries. We have got the source data. We have splitted the data, means chunks. We have assigned the embedding number. We have given the embedding, initialized the embedding. So what we are doing now, embedding has been done, stored into vector database, right? Now till here we have done all the thing which we have to do before retrieval. Now in the LLM there is a two big part. One is before getting the result, you have to prepare the data, store into vector database. Then comes the retrieval parts. Okay, you retrieve the chunks as per the query from the vector database, and that chunks and that output is being stored, being fed into LLM model, and that LLM creates the final response. So now we have done the first part. We have created the embedding and put it into a vector database. Here we are using ChromaDB. Now we are going to retrieve the data. So how you will retrieve the data? With the help of a retriever, we are going to retrieve the data. So The search type is similarity. Similarity means the vector number which is similar near to each vector number. It will give you the output. Means the near to meaning output will be given. Okay, and then k is equal to 4 means the first four relevant results should be fetched. Means the first four chunk will be the fetched. We can also see that what all chunks it is being it is getting fetched. We'll see how it is done. So you can tweet on this k4 k10 top and number of chunks you can get it. And here itself the re-ranking optimization, what we have seen in our multiple previous video, re-ranking features come into the play, but we are not going to touch any re-ranking or hybrid search right now. We're just building a plain RAG pipeline. So r is equal to 4 I have given. That means the first four relevant output will be retrieved from the vector database. Okay, now we'll initialize the LLM by the OpenAI key. Once the initialization of LLM is done, then we will retrieve the output and give it into LLM. So we are giving it into this LLM. Okay, and what is this? This is the retrieval. What has been retrieved? So this gives you all the chunks. So all the chunks will be now given to the LLM model, and then the response will be created out of it. So we are invoking it here. We are invoking it with the help of the query. So query we have already written here. You can pass all this query as a parameter, but I have written it here. So query is given as a invoke to this, and this is getting invoked here. And from here we are also passing retriever to your LLM. What is this retrieval? Retrieval are all the chunks which are, or the documents which are retrieved from your vector database. Fine. So this is the query, and we'll see the response what it gives. So the retrieval QA combines multiple things. It combines the retrieved documents from the vector database. It combines LLM. It combines the context, and it combines the prompt, because we are invoking it with the help of the query. Query is the prompt. Okay, this itself is the prompt. Fine. So I'll run this one. The question is, has Shahrukh Khan worked in Dil Chahta Hai movie? So we know that Shahrukh Khan has not worked in the Dil Chahta movie. Let's see what output. I've already run it once. Again, I will run it. Okay. So you can see the query is this. Result is no. Shahrukh Khan did not work in Dil Chahta. The film mentioned in the context is Dil to Pagal Hai, no Dil Chahta. That's very good answer. The answer is correct. Now the thing is, it is getting the information from the retrieve chunks. Now we have to see what all chunks it has retrieved. So I have another code, because I have to edit this code. So for retrieving, getting the output of the retrieval part. So see here, this is our retrieval. It contains all the chunks. Now we have to see what is the content in this retrieval. Okay. So we'll go here. We'll print the retrieval chunks. Okay. The same question is there. My Python file is different. It is RAG demo testing. Okay, now you see chunk 1 and chunk 2. Why? Because in this one I have given k equal to 2, and it is getting what all movie Shahrukh Khan has worked on. And from these two chunks, it has the LLM has understood the answer is no. So if I give chunk k equal to 4, although the chunk information is same, because we don't have that huge and variety in our document, so it is getting the same chunk. If I give k equal to 4, you will see that it will take out all the four chunks. But all these similar four chunks are very similar. It's the exact chunks, but we are asking it to take four chunks, so it is just copying it. See all the chunk 1, chunk 2, chunk 3, chunk 4. Okay, if you have a variety of data, then you will get different data information in each of the chunks, and that chunk is pushed into LLM. That chunk is pushed into LLM when we invoke it with the help of this query, obviously, and then we are getting the response. LLM, with this input, LLM understands what should be the output. LLM doesn't use the data in which it has been trained. It is using the data which you are providing from this vector database. So this is what RAG is different. RAG makes the different pipeline, altogether different pipeline, because here we are asking LLM to use the intelligence just to create the response from the input what we are giving, not from the input what you have been trained into. Right? I hope you understand this. So this was about the RAG. This was about the RAG demo of a very simplified pipeline. In the production unit, or in the for the any project, you have to write. You have to make it everything parameterized, like your chunk size, overlay size, everything has to need to be parameterized. You have to add multiple optimization thing like re-ranking, hybrid search, which we'll see practically in the next video. We have already discussed that theoretically in our previous video. We'll see that practically. I hope I have made it very short, very quick, so that you understand it properly. You don't have to break your head to understand. This is not a rocket science. It's a very simplified way. RAG is being used into multiple projects. We also take interview for the people for the RAG project. So RAG, be good at RAG. At least be good at RAG before going into any of the agentic pipeline or a multi-agent model. Okay. We'll meet in the next video with the next optimization practical set. Till then, happy learning and goodbye.